Hi everyone. This lesson is going to go through a past exam question from a couple of years ago, I think it was. So here we go. We have a warehouse designed so the roof has a cross section modeled by this function. So that's pretty important. Might highlight that. The walls are vertical and are 17 meters tall. We must use calculus to find the volume of the warehouse, given it is 80 meters long, and include a labeled sketch. Okay, so first thing, this is a tech active question. So I'm going to grab my calculator and I'll go straight to the graphing app. I've already entered the equation here of our function and I'll just draw that. Now, I've got my view window on the initial settings and I don't see very much. So let's stop and think for a minute. Just a quick mental calculation here. If x equaled 0, that term would disappear and the function would have the value 25. So clearly I need to go a bit further up here on this vertical axis. So let's just go up to, let's go a bit higher than 25. Let's go up to 30 and we might step up in steps of 10 rather than steps of 1. And let's go and have a quick look to see what we've done. Okay, so this gives me the top of the roof, I suppose, and it seems to be curved. Now, they say the walls are vertical and they're 17 meters tall. So 17 meters is about here somewhere, and I don't have enough width on my graph to show where the roof comes down. I need to make the graph, the domain here, a bit larger. So let's go, I'm just going to guess, let's go about minus 50. It's probably too much, but I can quickly change it if it's too much. And then I'll go in steps of 10 so it's easy to see. I'll leave the vertical axis alone. I'll draw that. Okay, actually that wasn't too bad. That works all right. So I've got a lovely looking parabola here. And when the value of this curve is 17, so around about here somewhere and around about here somewhere, that's where the edge of the wall takes over and the wall is drawn. So I'll start to sketch that now that I've got a rough idea of what's going on. Just refresh my view there. So here we go. I have to do a sketch anyway, so this will be part of my sketch. So here is the curve. That's our function of x, which, there we go. Now, I know that that point there has, I don't know the x coordinate, but I do know the y coordinate of that was 17 from the clue in the question. And likewise, that point there, I don't know the x coordinate. So this is my x axis and this is my y axis. And then, all right, my next job with the technology then is to find the x coordinate of those 2 points. I can probably do that with gsolve and then do an x calculation. I'm going to enter the y value of 17 that was given in the question. Now there's my first point. It's x of negative 20. Let's try that again by hitting the right arrow and it jumps across y equals 17, x equals positive 20. That was nice and convenient, wasn't it? So I'll label those. That's positive 20 there, and that's negative 20 there. That would be the vertical walls, which are 17 meters tall. Now I better make a note of how I did that. So I was using my CG50 calculator. I went to the graphing app. Then I went gsolve. Then I went x calculation and I set y equal to 17 and the calculator gave me back that x equaled plus or minus 20. Nice. Now let's have a think about what we have to do with this information. So we've got the function, we've got the vertical walls, 17 meters tall. Use a calculus method, so that means I have to do some mathematical setting out to find the volume of the warehouse, given the warehouse is 80 meters long. I'm going to draw a smaller sketch now involving volume for a minute. So my warehouse has vertical walls, it has obviously the ground is flat. I'm assuming the ground is flat, and there's a curved roof. And the warehouse is a big long shape like this, and that's part of the curved roof at the other end. Now that would be, it looks a bit like a loaf of bread, doesn't it? But that would be a prism, because if I was to sort of draw in the hidden detail back there at the other end of this warehouse, it's a bit rough, I know. The two shapes at either end are the same. So if I shade the area here, I'm going to call that the area of the base, or just area, and this length across here will be the height of my prism. And I'm going to work with the old volume equals area of base multiplied by height. That's a middle school formula there. So my question involving calculus for Year 12 methods is to find the area here. Now the area here is definitely something we can do. And here we go. The area of, oh, I'm still on blue. Oh, sorry about that. Uh, Remember, only a blue and a black pen during your exams. So you have to be, I normally do the working in black, and any highlight I might do in blue. So I'm looking for an area. It's a definite integral going from negative 20 to positive 20 of my function, which was 25 minus x squared over 50 dx. So the integral of the number 25 is 25x. Now I've got an x squared. That's going to become an x cubed. There's already a 50 there, and now I have to divide by the new power, so there'll be a 3 there as well, and we're integrating from minus 20 to 20. So showing our working, it'll be 25 by 20 minus 20 cubed over, now 3 times 50 is 150. I can make that easier for myself. Now we're going 25 by negative 20 minus negative 20 cubed over 150. Now it's tech active. I'm allowed to use my calculator to help me solve this. And in fact, I could go back to the regular calculator screen and type all of those numbers in, but there's a much better way. I'm going to go gsolve, and then I'm going to go integration, and I'll just ask for the integral of this function from negative 20, so we just literally type that on the keyboard, hit enter, and then we type the upper boundary 20, and it shades it in for me, and I can barely read the answer because my graph's in the way. That's annoying. Let's try that again, but this time I'll move the graph upwards a bit so I can see. Integral from negative 20 to 20. That's clearer. It's 893.3 recurring. So that's the answer. If I did that big calculation, that's what I would get. Much quicker just to use that little integral function on my graphing app. And the examiner isn't going to be upset by that because you've shown the calculus and you've shown the substitutions. So we have 893.3 recurring, and that would be square meters for the area there at the end of that. Now we need the volume of the warehouse. It didn't mention the units of measurement. I'm just going to assume, oh yes it is, it said meters there. I'm just going to assume all the measurements are meters. So here we go. The volume equals the area of the base multiplied by the height of the prism. We have that the area is 893.3 recurring, and the height of the warehouse was 80. So back to the calculator for this one. Oh, something weird happened to my calculator then. For this one, I will go back to the menu. And 893 point, just put a few of those decimals in place, multiplied by 80. And that's a big number, 71,466. 71,466. I'll round to the nearest cubic meter, and that's cubic meters. And that is the end of our question. Let's go back and double check we have answered the question. So did we include a label diagram? Yes. Did we find the volume of the warehouse? Yes, we did. So we're good. We're done. Thanks for watching.